Continuing from the last lecture, here we are discussing the losses of DC machine. As you know, in case of a DC machine, the losses are mainly frictional losses and windage losses, which are a kind of mechanical loss, then air gap flux linkage blockage, then armature voltage drop losses, armature reaction losses, and brush drop. In case of a generator, first of all we will consider the first loss, like that. If we are considering this is a generator and here it is moving with some prime mover, and this prime mover will be attached with a shaft to this generator armature, the rotor part, and when this shaft is moving, then there will be a frictional losses inside the bearings. As well as for cooling arrangement of this generator, there should have a fan like setup, and due to that there will be a windage losses also in case of a air friction with this fan. So first of all we get number 1, now, and windage losses. Then when this loss happen, after that at the same time, due to these poles, if the field fluxes are generated, then like that this is the direction of the MMF, and some part of these fluxes also being lost in the air gap. Some of this part will be lost in the air gap, so that's called the air gap flux leakage. This is loss of MMF. And thirdly, when this happening at the same time, if a load is connected through the output of this generator, then a current will flow through the armature coil, and due to that the generated inside EMF inside the armature coil will make flow of current, and this armature current will make a armature reaction. So this reaction on the pole side will make a armature reaction loss, because the field fluxes will be decreased. And this is our third one, losses. This is armature reaction loss, and this 2 and 3 are actually mostly decreasing the MMF of the field. So these two are actually decreasing the mmf. Okay, and after that, when its current is flowing through these armature conductors, a resistive loss, that is IR loss, will happen inside this armature conductor, and that will make a drop in armature voltage. That means EMF will be reduced, and that called armature voltage drop. The fourth one, and after that, this current, armature current, when flowing through this armature conductor, at the very contact of the commutator and brush, there also a loss will happen, and that called the brush drop. This is also one kind of resistive loss. That is the fifth one. This is also proportional to the current is carrying, that is proportional to IA or IL rather we say it, and this one will be proportional to IA, that means armature current. So actually these two are making drop of mmf, and these two, that means 4 and 5 are making drop of EMF or voltage drop. In case of a motor, this just happen in the opposite way. Like at very first, in case of, if we consider the second one as a motor, then at very first, from any DC source, if we supply VDC, consider VDC, if we supply a current that is called I, then it will come through the brushes and the commutator segment setup, and the first loss will happen, that is brush drop loss. After that, when it's come inside the armature voltage will drop due to what? Due to this current will carrying, the current carrying through the armature will make a drop inside the armature, and the nature of this drop will be a resistive one, and that is the value of the drop will be equivalent to IA RA, where the RA is the armature resistance. And then the third one will happen, the armature reaction. And why reaction loss? This will happen due to this current carrying inside the armature conductor. It will make a opposite nature of flux, and this will react with the pole fluxes, and it will make reduce the pole flux, you know that. And so the third one, from the opposite direction, the third one is happening. After that, at the same time, the air gap flux leakage is happening inside the motor also, if we considering the second one as a motor. And after that, as per left hand rule, if the motor start to rotate, then what will happen? There will be, due to the rotation of this motor, there will be, that means this motor also will be attached with some sort of spindle and to mechanical load. If we consider it is a brake drum, to that will be, with that it will be attached, and when you try to rotate this brake drum, at the very outside, the very opening of the motor, where the spindle are attached with some kind of bearing, there will be a frictional loss will happening, as well as the same kind of fan setup they are also inside the motor to cooling up it up, and due to that fan setup there will be another windage losses also. So for what we find here, that in case of a generator, these losses are first frictional windage loss, this air gap flux losses, there are armature reaction loss. These 2 and 3 are making drop of MMF, and then the armature voltage drop and the brush drop. These two are making EMF drop or voltage drop. And in case of a motor, it is just operate in opposite manner. That is, first the current is coming from outside and the brush drop is happening. After that, current goes inside the armature, then the armature voltage drop is happening, that is IARA drop. That is this one. And after that, due to this current inside the armature, the reaction will happen. After that, due to this reaction, and there will be some pole flux decrement, and as well as due to the air gap in between the stator and rotor, there will be air gap flux leakage, and these two will make a reduced of MMF. And at very end, there will be a frictional and windage losses. That means in case of a generator, it's operate like this manner, and in case of a motor, it operate just in opposite manner. That means 5, 4, 3, 2 and 1. Thank you.